Testing 1, 2. Right. While I wait until I have more viewers, let me do one more. That is n equals 5. I guess I can just copy this and then paste it and then remove this block. And then remove all the commas, I suppose. What about removing all the commas? I have a like, I have no idea why. What? Well, not even doing anything yet. Well, not really. I think you would like. Okay, putting each on its own line. These are all the elements that I made for n is 4. I'm just waiting till I have a few viewers. While I'm waiting, I'm just doing this manually. I guess in a bit I'm going to write a small C++ program to do this. Okay, so we have A, B, C, D, and I want to add an E. And then there are two possibilities. Either E goes into the same group as A, B, C, D. Oops. Or the E goes into its own group. I'll explain in a bit what this all means. In this case, I have two groups inside here. Which means we'll get 2 plus 1 is 3 possibilities, namely E goes into the first group or E goes into the second group. Oops, that's the same thing. E goes into the second group, like here. Or E goes into its own group. Now this one also has two of them, two groups. So we get 2 plus 1 again, meaning that E goes here, or E goes in together with C, or E goes on its own. And that one is also two groups, so we get also 3 here. 1, 2, 3. And then again, E goes in the first group, or E goes in the second group, or E goes on its own. Well, my viewers are slow today. Yeah. I'm trying to solve something. I thought, you know, normally the viewers ramp up quickly. So maybe in a minute or what, and let's say I want to get over 20. Well, I was waiting for 20 viewers, but maybe 10 viewers, I don't know. When I get to the bottom, I'll explain it in detail. So this is 1, 2, 3, so I'm going to add 3 plus 1 is 4 here. And then I'm adding E in the first group, or in the second group, or in the third group, or on its own. And this one gives question link. Well, it's above here. This is the question. Well, I was formulating the question actually for the math channel on ISC. And then I thought, why not start streaming it? This is 2 groups. Okay, maybe it's a bit tedious to do all of these. I can already generalize it. But anyway, E goes in the first group, or E goes into the second group, or E goes into its own group. And then we go, oops, this one has also 2 groups, so we get also 3 groups here. 1, 2, 3. Or E goes in the first one, or it goes in the second one, or it goes in the group on its own. And this is 3 groups, so now we get 4. 1, 2, 3, 4. And then E goes in the first one, or in the second one, or in the third one, or on its own. I don't have a square bracket here too much. This one has 2 groups again, so I'm gonna have 1, 2, 3. And then E goes into the first one, or in the second one, or on its own. I'm amazed that the number of viewers does not ramp up. Normally I would sit in 20 by now. But okay, I'm just going to go to the bottom, I think. 1, 2, 3, and then I'll start explaining. So E goes in the first one, or in the second one, which is over there, or in the on its own. This one has 3 groups, so we get 4 of these things. 1, 2, 3, 4. D together with D, or on its own. Okay, so the first question is how many different ways are there? Hey bear. 1, 2, 3, 4. How many different ways are there to partition 5 elements? That's for n is 5. That's what I'm working on now. So partition means group them. And so if you have 5 elements, A, B, C, D and E, then either they are all in the same group, or they are, for example, partitioned like this. A and C are in the same group, but B, D and E are in a different group. Or A and C are in the same group, and B and E are in the same group, but and D is alone. So this lists all the possible ways that that we can partition 5 things. The first question is basically how many ways are there to partition n elements? So I have to generalize this till we get a formula. I'm just going to finish this and then we're going to generalize it, okay? So either it goes in the first one, or in the second group, or in the third group, or on its own. And then we get this one, which is 1, 2, 3. So that's again 4 groups. 1, 2, 3 and 4. And then E goes together with the E, or together with the B, or together with the C and the D, or on its own. And finally, and yes, finally I have more than 10 viewers, so exactly when we are at the end. 1, 2, 3, 4, 5. And then E goes together with A, or it goes together with B, or it goes together with C, or it goes together with D, or it sits in a group on its own. Hello, unknown user. Okay, now 15 viewers. I'll explain what the problem is here. So the problem is that we have n elements. For example, this is for n is 6, A, B, C, D, E, and F. I want to partition them. That is, put them together in groups. So for example, A and D sit in the same group, and B, C, and F and E. This is one way to group them. Here you see all the possible ways to group them with n as 1. It's just A. You have only A, so there's no grouping, it's just A in its own. If we have 2, then either they sit in the same group or they sit in the separate groups, right? With 3, either they sit all in the same group, or they sit all in a different group, or A, B sit in the same group, or A, C, or B, C, right? And so on. So this is for 4 and this is for 5. Now we can, the first interesting question would be the number of groups, let's call that G. What is, hello, what is G as function of n? What is this formula? Write a formula for n. Now, you can of course say, okay, I'm going to do it manually, which is I just did here, and then we get the number of groups for n is 1 is 1. That is this one here. And for n is 2 is 2. And for n is 3 is 1, 2, 3, 4, 5. And for n is 4 we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And n is 5. Uh-oh. Well, 1, 2, plus 3 is 5, plus 3 is 8, plus 3 is 11, plus 4 is 15, plus 3 is 18, 21, 25, 28, no, yes, 31, 35, 39, 43, 47, 48, 49, 50, 51, 52. I think it's 52. I better make sure, because I'm actually going to use that. Let's put them in a nice column here. Okay, now we should be able to count them. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 times 3. 14 times 3. 42. 42 plus 2 is 44. 45, 46, 47, 48, 49, 50, 51, 52. Okay. Well, maybe this is already enough to find the formula. I'm just curious. Let's go to the integer sequence database, something like this, with commas. It says, okay, 1, 2, 5, 15, 52. 1, 2, 5, 15, 52. Is this the only one, or am I missing something? There's a few links about it. Holy moly. Oh, there's another one here. Yep. Okay, there's multiple ones. Yeah. Number A and K of set partitions of n such that all absolute difference between the least element of consecutive blocks are less or equal k. Nah. Number of partitions n such that... That doesn't really sound like it. They talk about partitions, but... This is just somewhere in the middle. That was all. Okay, gonna scroll up. I think at the very least we have to we need something that is beginning with it, beginning with this sequence. There's 1 1, yeah, maybe 0, you know. The next one could be 203. Word structures of length n using a 6-array alphabet. I don't think so. Number of length n inversion sequences, doesn't sound like it. Number of length n inversion sequences of 1, nope. I think, oops, there's another one. Word structure of length, also not. Hopefully it's the first one, which is very, very famous by the looks of it. Very famous. Bell or exponential numbers, number of way to partition a set of n labeled elements. Yes, that is exactly what I wanted to have. This is what I was looking for. So the next value is 203, I guess. More importantly, I just want to have a formula. I saw the word formula. Okay, now to make sure, I'm going to reason about it anyway, just for the heck of it. So I think that we can figure out how this works by just looking how I generated this manually. Let's say I want to know how many, not just how many weight partitions there are, but I want to know how many groups there are. So I want to know how many partitions there are with a given number of groups. get what I mean. So let's say the number of groups. Let's call that G then, I don't know, capital G. So the number of groups is, no, I want to know the number of partitions with the number of groups. So the number of groups there can only be one group when we have one element, and the number of partitions that have one group is 1. That's just one group. A group is with in the braces. There is only one group here. Then for n is 2, we can have also 2 groups. So we have one partition with one group. That would be this one, just one group. And we have one partition with 2 groups. That's that one. Okay, so fill that in. And then for the next one, you can have 3 groups as well. So how many do we have with one group? Well, of course, always 1, because one group means you put all n elements into one group, and there's only one way to do that. How many ways with 2 partitions? So that should be 3, right? 3. So that is 1, 2, and 3. And then we have one group with all separate. So this is also always a 1. Oh, whoops, this is a 1, and then we add a 4 here, which is also going to be 1. And then for n is 4, how many partitions do we have with 2 groups? That is 4. 2 groups, that is 1, 2, 3, 4, 5, 6, 7, 7. Now, so the rest would be if I count it, but I want to check myself. So I'm going to count the number of partitions that has 3 groups. For n is 4, which is 3 groups, right? So this is 1, 2, 3, 4, 5, 6. Now let's add them. 1 plus 7 is 8, plus 7 is 15, so that's correct. And then the last one is we can have n is 5, so we can have 5 separate groups. There's only one way to partition that. There's only one way to put them all in one group. And then the number of partitions with 2 groups is can we already see that? I'm gonna guess 15. Just because. One less than 2 to the power. But let's count them. 2 groups, right? Okay. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. And the number with 3 groups is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 here, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25. I'll be right back. I'll have to put on my light because I'm sitting in the dark. And then let's close the curtains. I'm back. Well, I think I did that correctly. So I have here the last one should be 52 minus minus 1 minus 15 minus 25 minus 1 is 10. I'll go for 10 here. Yeah, that should be pretty easy to find a formula for that. Because every time the previous n has a number of groups, we can put the next element either in one of those groups, keeping it the same, or put it in a separate group, giving it, making the number of groups one larger. The goal is too difficult to explain. So I would take world domination. Yeah, that's a good one. It has to do with my Vulkan engine. That's all I can say. The end goal is to write an algorithm that divides shader resources over descriptor sets. So each letter here is a shader resource, and each group is a descriptor set. But this is fun, just all by itself. So you can forget about that if you ask me. Yes, I'm Dutch. Okay, so let's say we have, like in this case, we have two groups. Yep, and we add an element, and the element goes in the first one or in the second one. And in both cases, the number of groups remain the same. Or it goes in a group by itself, in which case the number of groups increase. Therefore, I'm pretty sure I can make a formula. Let's call this h as a function of n and g. Let's rename this n. So a capital N is a bit strange. N, and this is g. And the number, g. And the number that I'm listed here is h, yes? So h of 3 and 2 equals 3. Yep, and age of 5, 4 is 10. So as an example, age 4, that's n, comma 3, that's g, equals 6, and so on. Then we know that the age of n plus 1, sorry, the other way around. The age of n plus 1 comma g equals, think about that. I think h n comma g. So we have, this is the number of groups, so we are going to put one extra element in it. We have h ways to partition it with already g groups. And we're just putting the new element in one of the existing groups, not incrementing the number of partitions. So g returning the number of partitions is then equal. But we can also get there by putting it in its own partition. So we have to add to this h n comma g minus 1. So if you have one group less, then for each of these partitions we can put the new element into its own group. That would be this number of partitions. I think that's correct. So does this work? Let's say test it out. I need another formula probably. Well, of course we have this one. And we have it's probably better to remove that one here and just subtract one from n. So this simply says that any element here is the sum of the one above it, that's this one, plus the one diagonally above it, but that's not correct. 1 plus 3 gives me 4, not 6. Oh, what am I missing? New. Okay, why am I so stupid? This cannot be difficult. How do we get this 25, for example? I counted it, right? So that's all the groups that have 3. So it's for n is 5. All the partitions that have exactly 3 groups. 25 is a lot, but it exactly gives us then a lot of information. So I'm going to mark them 3 groups. This is one group. I'll put it in front of it. One group here. This is two groups. This one is two groups. This one is two groups. This one is three groups. This one has two groups. This one has two groups. This one has three groups. Okay, two groups. Let's do it like this. 3, 2, 2, 3, 2, 2, 3, 3, 3, 3, 4. Now, this case I put the E in the same group as the AB, but since there are two groups, the next one is exactly the same. So if I have a 2 here, I am going to have a 2 here. Simply because 2 is larger than 1, and yeah. So 2, 3, because the E is now put together with the C. And then this is again 2, and this is again 2, and this is again 3, and this is again 2, and this is again 2, and this is again 3, 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 and this is again 4. And then this one is now the same number if it is larger than, sorry, yeah, the value is larger than 3. Otherwise it's one more. So this is 2 becomes 3, 3 remains 3, 2 becomes 3, 2 becomes 3, 3 remains 3, 2 becomes 3, 2 becomes 3, remains 3, remains 3, remains 3, remains 3, remains 4. And is that correct? 3, 3, 3. Yep. And now 3 becomes 4. And 4 remains 4. And the last column is 4 becomes 5. And now my question was, where does the 25 come from? Well, that's all the 3's. And if you ask me, the 3's are equal to the number of partitions for n is 4. These are just all the elements with n is 4, right? I just put them here vertical. So all the elements, all the partitions for n is 4 that have two groups result in two groups times the number of groups. Ah, oh, yeah. Okay, those formulas are completely wrong. So there's g times that. The number of groups times, yeah. This might be alright. So we have to multiply with the number of groups. So in this case it is 3 times 1 plus 3 is 6. And the 25 is 3 times 6 is 18 plus 7. 25. 10 is 4 times 1 plus 6 is 10. The 15 is 2 times 7 plus 1 is 15. So this is the recursive, the correct recursive formula. So now I can easily generate that one for n is 6. That's a 1. This becomes 2 times 15 plus 1 is 31. 3 times 25 is 75 plus 15 is 90. 4 times 10 is 40 plus 25 is 65. And 5 times 1 is 5 plus 10 is 15, and then we have an extra 1 here. And if we add up all of those, yeah, am I going to do that from my head? No, let's not do that from my head. This is 1 plus 31 plus 90 plus 65 plus 15 plus 1. 203. Which indeed was the next number, 203. So I'm guessing this is indeed the correct sequence. But that was just for fun, right? So now we know how many partitions there are. So I can work on my question here. With a total number of possible ways to partition equal to bloop, this link. Right, then the question is I need an algorithm to find the best partitioning such that a certain weight is minimized. The weight is the sum over all pairs. What's n times n minus 1 pairs divided by 2, I guess. Pairs W mind you, though, I'm writing this question to ask on IRC in the mathematics channel, so they can read this easily. Um, yeah, how to formulate this? I don't feel like doing it brute force anyway, because you know there is very quickly very large. At least I could do it brute force, say up till this value maybe, even that is 27 million already. And it's like n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Well, maybe. Well, no, 13, that's 13 chat resources. Yeah, that's a bit, it's not very much, is it? But on the other hand, if you want the perfect solution, it's probably going to be way too difficult again. Okay, what I have is that I have a penalty for two elements not being in the same group, or being in the same group, or both. And I don't know how to write that down, such that not everyone immediately gives up when reading the question. I think the whole question is going to be too difficult for anyone to be interested helping me with it. I'm gonna read the chat. What is Fat Man talking about? Yeah, I don't understand what you mean, Fat Man. A bool statement. I mean, what is a Boolean statement? With regard to your prime program. Without showing code, it's going to be hard to help, I'm afraid. I think this is not interesting anymore, is it? Unless I want to brute force it. Fatman, if you paste a link, then we don't see it in the chat. They are silently suppressed. Sorry. It's simply not allowed to paste links in the chat. That's apparently anti spammers. Maybe it works if you just type everything of the link except the HTTP slashes, colons and dots. Well, you can message me on. You can paste the link in Discord, but you can also just type it here and then disguise it in a way. I think you could do something like domain org, like that. That doesn't look like domain. Oh, I'm completely stuck on this problem. I think the number of things that we have as well currently is pretty limited. So brute force might be possible. Okay, so the problem is that, say, I have a list what says that if A and B are in the same partition, then you get a penalty. And if D and C are in the same partition, then you get a penalty. And I also have a list that says if A and C are not in the same set, then you get a penalty. So for both, for every pair, it is possible that I have specified that you get a penalty if they are in the same group, and or if they are not in the same group. And then I need to find a partition that gives me the least amount of penalty. And the only thing I can think of right now is, I mean, to brute force it, but that would be pretty damn slow, of course. It seems better to be smart about it. And I thought that maybe if I can pour the whole thing into a matrix equation, then I can be smart about it. Although that seems pretty unlikely. It makes me think about this problem that someone in the chat asked a few days ago. So rather, it was a problem from one of those coding sites. So the only thing I could come up with is a brute force thing that timed out, and in fact you could write it in a linear way. It was way faster. Definitely that makes me think of it. And they had a pretty, the eventual solution was pretty smart. Now I have the feeling that maybe I can apply the same solution to this problem. For example, I could start with, yeah. What was that? I'll try to find it back. What was that called? Something with rain. Well, anyone here who was there as well then and who can still remember the phrase that we typed in to find the solution? Our memory's too bad. Anyone listening to me? Chat? Hello? Yep. Nope. What other words do we have? Trap? No. That was one of the links, but it was not related enough. But trap was, I think trapping was a word, it was part of it. See, trapping rainwater uses very thick walls. And it traps more than one volume. It's might be related as well though, but the other ones gives me the feeling that it was more related. So three-dimensional. So problem, interesting. Yeah. My browser history. I'm afraid I looked at a shitload of things. How long ago was it anyway that I looked at this? I think this is it. It was from lead code, and then later I was looking at for the literal string indeed. Container with most water maybe. Yep, that's it. Very good. At least I can read fast, so we found it quickly. So this is my brute force solution, I think, which is not very smart. The trick is that they start with the outer walls, and then they just move one wall inward, either left or right. And they move inwards, and the lowest wall is moved inward. And the reason that that works is that yeah, I must say I don't really understand why it works. Damn it. But why does that work? Now this example is almost evil, because if you would do this with the correct algorithm, you would immediately find a solution. You would start with the outer walls here, so you only trap this amount of water, and then this one is higher than that one, therefore you would move this one inside, and then you find immediately the right solution. Okay, anyway, this is the highest wall, so next you would step this one inward, and that would be obviously less, because both horizontally as well as vertically is less. And this one is still less than that one, so you would just step inward until you find one that's larger than the one that you had, so that would be this one. But even though it gets a little bit higher, you lose too much horizontally. It's not high enough. Now let's say that this black one here is higher than that one, so then next you would move this one inward, but you will never find anything more anymore, because everything that's inside here is lower than that one. But if there was anywhere, say if this one was way higher and there was any here that was also way higher, so that the volume between those two is larger than the shown volume, then you would find this one by stepping inwards until you find the way higher one, and then you step with this inwards until you find the way higher one. And that's linear, because you just, from both sides you do one step until you found a solution, instead of brute forcing going over all the possible pairs. Can we apply that same way of thinking to my problem? For example, I could think of these two outer walls as being the two possible partitions that I have, with everything in its own group or everything in the single group. So I could say this is one way and this is the other way, and now I'm going to change it. Now this has a volume. This is I can calculate a penalty for it, and this one as well. And now we're going to make one step either from one side or from the other side, where a step means that we, in this case, we pick one of the things and we put it in its own group, because that would be a minimal step. For example, I could go from this one to this one, let's say, to taking E out of it, or you can take D out of it, or C or B or A. Which one shall we take out of it? So it's more like a multi-dimensional problem, where you can step from multiple sides. I mean, this is clearly one-dimensional, right? But you can make it also two-dimensional, I suppose. Yeah, so let's say instead of being able to step from, let's say this is the point, the wall on the left side, and this is the point on the right side, then we have to investigate both in one way or another. This one is on the left side, and it's not that you can simply do one step to the right, from here going to there, or from here to there. There's always one direction, there's only one step, there's only one way to change this. And there are more like 5 different ways you can change this. But maybe I can just try out all 5 And then in this case, that would be, we just pick A, B, C, and D and or E, and then we do something with it. And doing something with it means you move it to a different group. Either a totally new group or an existing group, I guess. For example, if we are here, then I could move E either to the CD group, or I can move E to its own group. And then the same for B and for E, but it's that's quadratic, but it's should be pretty still easy doable for a computer. It's not really linear anymore, but and now from the other side we can also do the same kind of approach. I have A, B, C, D, E, and I can just start with picking one of them and then move them to a different group. So I say I pick A, I just get rid of it, and I put E then in D together with D or C or B or A. That would be one step. Now, the main question, of course, is will doing that give me the best solution eventually? And I don't even understand why it works for the single. Now, I mean, since this gives me the insight for this algorithm, I'm suddenly having more respect for the questions that they ask here. These are apparently questions they ask during an interview. So yeah, if you know the answers to all of these questions, you might actually be better in solving algorithms. It does give it's usable in more way than one, I guess. Brute force would mean that I generate all the different partitions, so all of them that I just wrote out here, and then calculate the penalty for all of them, and then pick the partition that has the least penalty. But that grows quickly to in the millions or billions with a lot of elements, as we saw on the integer number base database. Now, for example, say that A and B being in the same group has an extremely high penalty, very high. Then I might come to the conclusion, if we start with this, that I have to remove either A or B from this group, because removing C, D or E hardly does anything. It seems very logical. There might not be any difference between removing A or B, but if that's the case, it is randomly remove one of them, that doesn't matter. And if there's a little difference because, for example, B and C in the same group also has a penalty, then I would prefer removing B, because then I get rid of the very high penalty and I as well get rid of a little penalty. So then we would end up with, well, do you see it? This one. Be removed from it with a much lower penalty. But then after that, I would never want to put A or B back together. Now, even if I would just still be rather naive and simply try everything by moving one element, that would still work if I would demand that the penalty only gets lower. For example, I would have this, and then I would consider moving B back into this group, and then I would get back my super high penalty. So I would never do that. I would I only want to go lower. Okay, you found it. Thanks. Good. The question is, if we do this step by step, so moving one element at a time, will we always find a minimum? You don't even have to walk from both sides, actually. You can just start in one thing and then do the one step at a time, and you would always end up in a minimum. But is that working? Will that work? Shall we write a little program in C++ just to play with that? Test it. I think that's a good idea. Okay, going to write a program for this. How are we going to store these things in an efficient way? Because I want to brute force some stuff, I guess. I'll think about using a bit pattern. I have integers of 64 bits, so if I would work with a maximum of 8 elements, it's not very large, but might be large enough. I'm not sure. If we go back to this this is 1, 2, 3, 4, 5, 6, 7, 8. So 8 only has 4,140 partitions. It's not really suitable to test if we get a high speed up, I think. I want to go to 16 at least. 8, 9, 10, 11, 12, 13, 14, 15, 16. Now that would be nice. If I can do it with 16, then in a short moment, a few milliseconds, say, then definitely is working. So I could try, still could try bit patterns, but then I need 16 times 16, is that not 256? It is, so I need a bit pattern of 256. Which is 4 integers. That's still doable. So I get it. I don't know why. I'm just having a random idea. That's just a random idea. So maybe it's a better way. But my idea was then that if we have ABC, ABCD, we can, this example, n is 4. So then the maximum number of groups is 4. Obviously, we only have 4 elements, so the maximum number of groups is 4. So what I could do is I call this a group, and this is a group, and this is a group, and that's a group. And then we put A in this group, and B also in this group, and C and D not, and then let's say we put C in this group and D in that group, and then this is unused or whatever. It's a 4th group. We don't have a 4th group, so this would be AB, comma C, comma D. That's this one. That would be stored like this. Although it's a bit redundant because the exact same thing is, of course, if we swap them out. If we do this, I mean, that would be exact same thing. It is one unused group, and this group contains A, B, and that group contains D, and this group contains C. But using those bit patterns are going to help me. Maybe not. It might help me to quickly find other ways to partition by moving just one single bit. The point is that we have exactly 4 bits set, so this has 4 ones. And well, everything has that. In fact, we could say we could make a canonical solution where we demand that we have the lowest value, and that means that this is the most significant bits. We make them all 0, and then we do that one, and then that one. Then that one, and then that one. So this would be the lowest possible integer value if this whole thing was 16 bits integer. Then this would be the canonical way to store this. And if now I want to, which makes it easy to compare partitions. So 2 partitions are the same, we just compare 2 integers and we know that it is the same. And if now I want to swap out one element to a different group, I would have to do let's say we swap A. If we swap A, there's just 3 possibilities, right? Either A goes here, I said 3. Either A goes here and then it's gone here, or A goes here and it's gone here, or A goes here and it's gone here. And then we have to reorder this to get the canonical version again. Each of these things have a different leading number of zeros. This has 4 leading number of zeros. This has 3 leading number of zeros. This one is 2. This one is 1, and that one is 0. How can I suddenly have all of them? We don't have 1. I don't see where I saw the 1 here. Oh yeah, because I removed it. Now suddenly we have 1. Which is encoded as, given the group, the first element that is in the group. So B is the first one here, A is not in it, and there can only be one the first, and B is only in one group, and therefore the number of leading zeros are different in all of them. So I want to do sorting. We have to just swapping those bits is not enough, right? I think we want to sort things as well. So maybe I should just store this in an array of size 4. Now we can even go up to 64. Well, that would be ridiculous. So let's make an array of 16, each with 16 bits. And that's how we're going to store it. Or the 16 can be variable. Let's make it using a type def. Let's start coding. Let's go again to a different directory. Before we were in C++, and I made the number wall thing. So let's call this one partitions. CD make dir partitions. CD partitions. Okay, I'm definitely going to print debug output, so let's do IO stream, and we're going to have a main function. Typical hello world. Now we're going to have a class. The first class that we have is a partition. No, an element. So we need an element. Each element has a name. The name is, well, one character would be enough if we go to a maximum of 16. Let's just not go further than 16. I don't know. It's good enough. Also, I was going to do the base type that we're using. So the bit pattern of, let's say, how do you call this? A bit pattern where each bit means an element. Let's call that a group type. I don't know, just random group type. We're gonna work with 16-bit. I do not have fat fingers, but it looks like it. I wanted to have a T there. Are we done? uint is probably C standard int or something like that. And if not, then we'll see it. Okay, so I'm gonna have a name. I keep using my m underscore prefix. I'm used to it. I don't know. At least I can see that it's a member. I'm on this name. It's just a single character. And it is already private, but I like to make that very clear. And then at some point you get public stuff. Pubic is something else. That's why it was red, I think. No, it was red because I thought it was a lib. Well, each element has a name, but I might as well add a group type with a bit. The bit that it belongs to, for fast access as it were. I don't know. Elements. We probably also need to enumerate over them, right? So let's make a class called element index, which is just an integer. So this runs from 0 till 15. So yeah, we will also have an element index. Let's create them by index. Seems like the most logical thing to do. Nothing else required, I think. So then the name becomes index to name of the index, and bit becomes obviously index to bit of the index, and mindex is simply index. Could make that a free function, or I could make it a private function inside this class. Might be sufficient. I'm not sure how often else I have to do that. So let's start with this. Car. Actually, it's a static function because it has nothing to do with the state in the class. Index to name. Now in this case we really need an integer, so I'm just gonna add a get value for that. And then here as well. Hello. Public int get value. Of course, I can just not use element index, or do a using element index is int. But I'm a bit careful in the case, you know, need to do weird things with it later on. It's always nice to have a custom type for everything. And I must say that I'm especially doing this because it's educational, I think, to show you using classes for everything. We also need an index to bit, so that returns a group type. Index to bit. Which then returns the group type 1 shift left shift index get value again. Okay. Which then of course needs an assert that the index is not so large, so we shift it off out of scope. So in this case index get value must be less than the number of bits. I think we have a bit width or something like that. Well, let's just use the size of times 8. So the size of the group type, which is 2 times 8 is 16. Well, it must be less than 16, otherwise we'd shift it off out of the type. And it's automatically then, if ever I change this, say to uint 8 or uint 32, it's gonna work still, because then size of changes along. For the assert I need another include, include C assert. C stands for C because it's also a C header. Okay, I think that should do it. I'm going to, well, I'm at it anyway. No, I'm going to implement, I already have an index class in my utils library, which has a get value. And why not implement it or write this a little bit equal. I'm going to, it's not the same by the way, but because this returns an int, and that's more like explicitly not returning ints. Yeah, well, maybe we should not. Okay, let's not do this. Sorry. I need to be able to add, I need to be able to increment it, that's for sure. I'm not interested in returning anything from my increments. I want a pre-increment, so this was operator plus plus. And that simply increments m index. Well, that does have to return something. It returns element by reference. Could add a post increment as well, but I hate post increments so much that I'm not even going to add it. Just let's use pre-increments. Well, we have to be able to compare the value with something. So let's add a bool operator equals. Let's use an unequal. I want to compare it with an element index, and that returns m index is unequal index get value. Oh, that's enough for now. I can make a for loop now. I need a begin and an end though. I want to treat those things as an iterator. Let's make static const expressions that are public, which I can just use directly. Static const expression which returns an index element, which is called I begin, I stands for integer or index, and it's just a 0. And I have another one which I call I end, and that's going to be 16, which is again the size of my group type times 8. Now we have a less than operator. I just compare index directly with I end, because that was the same value anyway. But we're not comparing the integers now, we're now comparing the element index. This is also an element index. So I'm also going to need an operator. Less than. In this case I'm going to make it a friend, just for variation. So we have a left hand side and a right hand side. Friend makes it a free function. So now we have, it is a binary operator, so we just have left and right hand side. Well, this is not a friend, so it is a member function, and then we compare the current object as the left hand side, and the right hand side is being passed to the argument. So in this case we return left hand side m index is less than the right hand side of the index. Now think about it, I'm always using friend functions rather than these member functions when it is a binary operator, and then when I do that you see how it changes, so why not? Let's make this a friend, and then we need another argument, yeah, because it's a binary operator. So we have a left hand side and a right hand side now. It's not const anymore, it's just a free function. because it's friend, we can access mindex directly, so I don't need to call get value to get mindex. I'm just accessing it directly. If it was not a friend, well, we put it outside the class, and well, now we could still do the same thing, but then I would have to call dot get left hand side dot get value instead. So same thing. Okay, well, we did already a lot of work, but the only thing we can do now is make a single element. But let's test it out anyway. So we make a loop. We want to, in the end, we want to be able to loop an index from 0. Can we initialize it with 0? Is that necessary? That might be easier to read, I think. So let's just allow that. And do I is unequal element index. And I end. Okay, that was nonsense. I meant, of course, I element begin. That's why we made it, the 0 there. I begin. So we begin with the value I begin, and we run till it becomes I end, and we increment it in between. And then we're going to create an element. Let's call that E from the index, and now we're going to print the thing. It's on a new line. Show all of them. Okay, we must be able now, therefore, to print elements. Don't have any support for that yet. So let's add that. I'm going to add that at the bottom because it's kind of a debug support thing. This returns a OStream reference, and it's called operator, and it takes an OStream reference. Let's call that OS, and it's going to print then the element, which will usually pass as a const reference. But as I showed in another stream before, I really hate these things because you have to type element all the time for everything that you want to print. So what I always do is, there's also a friend by the way. What I always do is simply on element, type element once and then call print on OS. And then I have to separately write that. Well, since it's a friend, I can even make print on private now, but why not make it public? So we're going to have a print on here that prints to an OStream. This is a const, it's not changing our object. And now we have, since it's just a member function, we have access to all these things. So I can just print mname and without typing element.mname. So let's write mname here too. I could also write all the other values, but just the name is I think all you want in this case. Let's try to compile this. No, made mistakes, has an incomplete type. That's true because type is not complete until you left function. So it refuses to make an element index. I guess we'll have to make it the global variables. I'm not sure. Normally global is evil, so yeah, not really super and what is the word? Not a big fan of it, but this is just a little test application, so I'm not going to be very worried about it. And static can be removed as well. Who cares about that now? And everywhere we use it, it's no longer a element of element index. So now we suddenly have to call it like this, which is kind of weird because it's just, you know, that's why I say I'm not that happy with it. They should call it, the word element must be in it somehow. Shall we do that or shall we not do that? I want to show you guys clean code, so let's do that. I want to call these hell, it's not how it works. Clean would be if we could treat these things as sort of an iterator, in which case this should be a function of something that is called a container. The container in this case maybe is element itself. Yeah, let's do that. Okay, it's clean enough then. So instead I will add these things to this class instead. Now we can do that because it's a different class, so element index is already complete here. And then, well, let's give it a slightly different name here. The S stands for static. And then I'm going to add as an accessor, I begin. It returns these constants. What am I doing? I int. It's kind of silly, of course, because of this. They're just constants. It's not like it's an actual array. So what I'm doing here is, you know, this thing is really just storing a group type. So wrap around the group type with the debug name and an index for fast access, but the index is simply the index of the bit that is being set in this mask here. But I'm treating the whole mask, which is an integer of 16-bit, as an array of 16 bits, and then we have an index begin and end. Yeah. Maybe far-fetched, but it works, right? So then we can do here now element index begin and element index end. Yeah, you have to admit that it sounds nice like this way. And now they are functions, so they even look more like begin and end of STL containers. Yay! Let's try to compile this again. Still not working. Ooh, lots of errors. That was more or less a typo, I guess. And then we have other typos. No matching function for call to element index brace and closed initializer list. Well, that's entirely true. So we want to be able to initialize a thing with an integer. Well, let's add a constructor then, which takes an integer, which is then the index we're initialized with, but it kind of feels stupid because it's really group type. So you're going to accept the group type and then use that to init. What is it, the group type? No, it's not. Sorry, this is just the index. It's just an int. Okay. I guess I should add an assert here as well. Right? Assert. Index. Oops. Index in between 0 and yeah, size of. Now I have to repeat what I coded below, so that kind of feels like code duplication, I must admit, but you can just assert this kind of belongs here as well, since you pass an integer. There's also a trick of me, you know, in mathematics you can write 0 is less than index is less than that. And in C++ you just have to do this then, index and index, repeat index again. It's kind of a nice way to, nice pattern I should say, to make sure that your variables inside a range, larger or equal 0 but less than 2 times size of. Next error. The type const element index of const expression variable is not literal. Okay. Oops. So actually two things. I just added this constructor. Well, I do not want to have an accidental conversion to int. I only want this constructor to work when it really is an int that I'm passing. Therefore I add explicit in front of it. So now you try to construct it from a double, say, then it should not work anymore, even though normally a double implicitly converts to an int. But also you have to tell it that this can be used in a const expression. If the index is a constant, a literal, then it's allowed to call this. And now it should compile that line as well, I hope. Okay, now we get an error here. Primary expression before, what is it? This must be size of, it's just another typo. In const expression expansion of, call to non-const expression function assert fail. Okay, so now since we are doing since now it is a const expression, you cannot do the assert anymore. Well, we might also use it as a non-const expression. In case it must be an assert, and otherwise we could change the assert to a static assert, but then we will not be able to use it anymore as a non-const expression. This is kind of difficult. I'm not sure how to solve this without templates and stuff like that. So, well, let's keep it simple and just not do an assert here. int is not a member of. Okay, I'm still having it as an element index. So. Cannot call a member function const without object. Okay. Yeah, well, we don't have an object, we don't need an object. And print that int really must be static, and so that's that one. We do not need objects here. Static member function cannot have a CV call. Yeah, okay. Forgot to remove the const after making it static. Finally it compiles. Okay. Now prints 16 names, A through P apparently. So what is next? We need a partition thing, right? I think we also have a group, or yeah, a single group. Let's make a group first. So do we still have? No, I don't. Okay, so a group is then also a wrapper about the group type, and in this case we really have a whole group. So that's a bit mask, multiple bits. Could call it just mask or value group. I don't know. Let's call it a group. So this can have more than one bit set. One element is also stored in a group type, but then we have just one bit set. And if we have multiple elements in one group, then we're going to have multiple bits set. Even 0 bits is possible, and it is a group without any elements in it. But, Well, and then we get all the boring stuff. You must be able to construct a thing. I guess we want to construct it from a group type, or do we not? Or do we want... I think we do not really want that. The group type with a single bit is wrapped by element. We could make a group with a single element, or an empty group, only an empty group. Let's make an empty group. Since group type is a built-in, it's probably better to use the braces here, so that the default constructor really puts 0 into it. So no bit is set, which means that there is no element in the group. And why not? If we ever want to construct a group from a single element, that should be possible, right? I don't see the harm in automatically converting an element into a group type. If that gives problems, if that would give problem, then of course we could also here do a get bit or something like that. But it's just more typing, and I don't really see the benefit. So we are going to allow that to automatically happen without a function name. And just like before in the previous stream, that means that I have to add to element something that does an automatic conversion to group type. And then of course we need to be able to set multiple elements in the group. And I'm just going to do that like add a single element, or just add 2 groups by merge 2 groups, add 2 groups. I think just adding a group to one group to another group. We want to treat this as a bit set. I could make an operator exclusive or. Oops. But yeah, we want to do all kinds of bit fiddling. We want to remove it. We want to add it. We want to toggle it maybe. Maybe I should use function names with just a name instead of an operator. That would hide the bit mask implementation, and I think that might be better in this case. Yeah. It's really an implementation detail, so I don't want to expose in the API that it's underneath we're using a bit mask. So let's say we do an add. What I really want to do then is add just elements, but multiple elements are, yeah, you know, they are grouped by itself. You could use it add or merge. I think add is more what we going to want to do. I'm going to call it elements here though. So we want to add elements, and then just return the current object after we added it, and then adding would mean that we just do an OR with the elements. Although I don't think in this case, I mean, it's so intuitive, but now I do not want to allow an automatic conversion to group type. So I'm going to explicitly call group soon, which is allowed because this is a member function of this group, so it is also a friend. So I can, even though this is a different group, sorry, yeah, different object, you can still access it. This should work, but something wrong is going on, I have the feeling, if we try to add elements to a group that are already in the group. We wouldn't be adding anything then. So I think I'm going to add an assert that makes sure that the elements that we try to add are not already in the group. So for any bit that is set here, we want to get a 0 because there must be a 0 in mgroup. In mgroup, that was group, yeah. So groups is not a thing. And then the comment, don't add existing elements, only add new elements. Now, likewise, we should have, of course, remove elements, which I then also call a group. Maybe I should call it elements instead of group. I mean, until now, I'm using it as a, yeah, it's a group of elements, but I'm going to rename it. I think that it's better to use it. Substitute group is elements, the plural of element, is that, I don't know. It looks much like element, that's it on the downside. But, well, what's in the name? Okay, it's going to be a lot like this one, I think. Probably, or maybe it's an error, so don't try to remove non-existing elements, which means that if we do an AND, it must be exactly equal to what you try to remove. And then this becomes an AND with the inverse of that value that resets the bits. Well, what else can we make? We can make a toggle if you really want to. I think it's extremely unlikely that I want to toggle more than one element, so for now I'm just going for a single element. And well, we don't really care if it is already set, of course, in that case. And this would be an exclusive OR with the value of the element. How do we do that? That was mbit, right? But in this case we are not a friend of element, so you really have to just call the get value. Maybe it should call that get bit. Do I have it? Element has a Oh, it converts automatically to the group type. Yeah, so we can just do that. Toggle the element. Yeah, what else do we need for elements? We need to be able to print it. Boring, but print on standard or stream reference so is const. We want to print the name of every bit that is set. I don't see another way than to just loop over all the elements in it. And then test if the bit is set. If m elements is what we store, that is just the integer, so I can just test if it is being set by doing and with that one bit. Yeah, well, also this is just a wrap around a single 16-bit variable, so I might as well pass it by value instead of a const reference. I don't think it makes a difference, but it almost looks weird, you know. For an operator like this, I always use a const reference, but of course passing it by value would be super optimal. Yeah, I think it's time to compile it again, test it. Let's construct an element. It's an empty element, I think. Elements, and then add a few elements. Let's say how about I just create an element by name for each of the elements so I can play with it easily. A stupid idea. A. Let's even test if we can do that. So I'm going to print A and B and C and D, and then I believe it. It is not working. Okay, loads of errors ahead again. Making so many errors, right? Forgot the return type here. Friend function definition cannot have a name qualified with std. What? What did I do there? I did start with the std of the O stream, and then I immediately jumped to operator. Elements was not declared in the scope. Do you mean elements? No, I didn't. What is that about? Elements. I'm calling it group. Yeah, well, why not? No, I'm kind of, you know, on one hand I'm called it group, and I'm using group, and then I renamed half of them to elements, and now there's still remnants of groups left. But, well, we get there, I guess. Eventually. Return a statement of the value. Okay, that was definitely stupid as well. Print on does not return anything. What else did I do? No matching function will call to, yeah, we cannot create elements from integers. You can only create them from element indexes. That makes sense. And element indexes you can only explicitly construct. Yeah. So if I removed explicit, it would work. Is that dangerous to do that, to allow that? I think it is. So yeah, it's just while we name these things, and it's not allowed to pass an integer, you just have to explicitly state that I want to create an integer. Sorry, to create an element index from that integer. So let's do something here with what? 0 to 9, any number of times. Brace with, it's not doing anything, so what if I add backspaces? That seems to work. And then I get element index. Right. A, B, C, D, okay. Well, I want to have the free choice of everything, so we need 16 of these. A, B, C, D, E, F, G, H, that's 8. Oops. Huh? Could also allow to create them from a character and then assert that it must be A through P and then make that work. So then you would have something like construct A from character A. Then you can even check better how, you know, yeah, maybe, well, let's do that. Why not? Gonna do that. It just feels slightly better. So construct them like that. It's easier to see that you did not make any mistake here. So now we're constructing element from a character, and that definitely must be an explicit constructor, right? So we have an element from a character, and we want that to be explicit. It must really pass a character type for this to work. Type name, and then mbit becomes yeah. I guess name to bit. I don't like that. I think I'm gonna do to bit name to index seems more logical, but named a bit, so then we call index to bit on that. The other way around. This gives me an index. That's what I need here, really. And here we have an index, so I must do in index to bit. We already have that one. And now I need to add the name to index. That takes explicitly an int, so let's just call this an well, probably if I just do name minus a, we get an int. Difference between two characters, is that an int? I guess we'll see. Oops. ABCD. So did it work? I think it works. Yeah, it worked. Okay, so nice. Now we can just play with it. So if now I do say I use a K here in the middle, and then we end with an N, and then we add a we add an E here. AKCNE. It prints it in that order. Yeah, of course. Now I'm going to make an element out of these things. So elements is empty, but I'm going to add a. Does that work? Going to print elements. That seems to work. Okay, that's nice. Now let's do KC and E. Yeah, the same things in the same order. That printing it ordered because yeah, it's just now bit mask and we're printing it as yeah from A to P, right? So that's also as expected, and it works. Finally, we can make say elements 1 and 2. And then I'm adding first to elements 1, and then I'm adding to elements 2, and then we are adding to elements 1, add elements 2. And now we're printing elements 1. I don't think this works yet, but let's see where that goes wrong. It seems to work. Yeah. Oh, okay, that worked here. Now, and then we can remove it again, right? So let's element 1 remove elements 2 again. So this should remove the N and the E. Oh, I meant elements 2. The N and the E are removed and acknowledged. Add and remove works, and now we can finally do a toggle. Let's say well, we can do anything we want really. I'm not worried that if I reuse elements 2 again, and it works, that it would not work for any other combination. So we do a toggle, then we get them back again, right? Not allowed. You can only toggle a single element. Okay, that's indeed what I wanted. Let me toggle M. We didn't use that one yet. So we get an arc there with an M. So that works. All of that works. My God. What else? Yeah, now we want to work with partitions. So this last class for the elements, and now I'm going to make a class that is called partition. So it's single partition or partitions? I think it was single, right? It's a single partition. And my single partition looks like as follows. I'll make it an array. An array of elements. Yeah, see, and now I want it to be a group, really, because this must be a group. Now a group exists of elements, but let's just do is lame and start to use groups here, because it's still elements, but now I can call it groups. So we have a groups, and we have a maximum of 16 groups, but that 16 came from this still the size of the group type times 8. Yeah, so it's single group. One group exists of many elements, and we have now groups. A maximum of 8 groups. Mario, it's like a demonstration of object-oriented programming. Adding one class at a time. Right, so I think that we must have a partition, and we are just going to start with one thing. So whenever I create this, whenever I create a partition by default construction here, we're going to have an array that is initialized with everything in one group. I like that idea. How do I add everything in one group? And that means that the whole array is empty except for the first value, but I want to sort them. Okay, let's sort them in descending order. So the first element must be the largest, and since all the other elements will be empty, those zeros, it is the first element that is filled entirely with ones, 16 ones. When everything is set, that means that we have just all of the bits of the group type set. Trick, we cast a -1. So this gives us 16 bits. And it's must be the first element of the array. So now we make an array of it. So we'll initialize the list, but okay. Now I have an initializer list with a single group type, while groups is an array of multiple things, but that will work. It will just fill the rest with zeros, or you can be more explicit and add a comma here. 1 0. I mean, it's just, you know, whatever it misses is going to fill with zeros. Maybe let's try to do it this way. I'm not even sure. Maybe this compiles. It's loads of options, I guess. I'm going to try this, and then we get something like, you know, just a comment, but everything is a 0. If I'm right, because you never know. Let's add a header for the array anyway, and then try to compile it. Partition is not an existing class. Partition. Narrowing conversion from minus narrowing. Well. Okay, we'll do it like this then. Just 0 and then invert it. Invert all the bits. Too many, what? Too many initializers for standard array elements 16. Yeah, well, really? Okay, I'm kind of stumped here. What's it talking about? I think it's interpreting this as a whole array then already, and then this is a second array. I would have sworn that you need 2 braces here, but apparently not. So let's remove a brace. Could not convert the inverse of 0 from int to elements. No, it's trying to convert that to 1 element. Well, I agree with that, but it doesn't allow me. And it's apparently not a group type anymore if you put that in front of it. Really, that makes an int of it. Okay, I'm going to try this. See if that was a problem. No, convert 0 from group type to elements. Yeah, it's the same thing. I must make oh yeah, it's a nonsense what I'm trying to do here. I made a single group type, but these are elements. Group, well, it's a group, but those are elements. So I do not need a group type, I need a group. That's what I need. And the group is elements, and elements can be constructed from a single element. That's not enough here. Not enough. Okay, then in that case I'll just have to add a constructor for passing a group type. Also making that explicit though. I'll not make it myself very difficult. So only if you pass explicit group type to the constructor of elements is going to accept it. And in this case, where are we? So that means that this must be an explicit group type. Now if I make a 0 as a group type and then I invert it, do I get an integer or do I get a group type still? Yeah, you cannot go from int to group type. What about inverting int? Oh, it didn't work with -1. That was a trick. I think -1 is better readable than ~0. Let's try this. Now it's a narrowing conversion again. I think it's whining a bit. Whining, that's what it's doing. Let's try to invert. So it's also an int of course, but it's still narrowing, still calling it -1 even. What? Yeah, it's calling it -1. It's the same thing. Oops. Okay, so apparently you have to do of course I can just specify that it is a really? So this is kind of confusing me. Why would the tilde inverted change it into an int? It's an unsigned 16-bit integer, and then the tilde operator should just keep it that way. let's try again to compile this first. Oh wait, maybe it's talking about this integer. Yeah. Oh no, no, it's really pointing to it. But okay, that integer is implicit. Let me try the comma. That worked. So we can do the comma here, and the rest is zeros. But I think if you leave out the comma, then it works as well. But this might as well, you know, I don't know. Maybe it communicates that this is just the first element. But I want my first element to have 16 bits set, not all zeros. Yeah, Anti-Toxicate says, why does he even stream if he doesn't talk through chat? Well, for one thing, we have currently 45 viewers and only 2 people that talk in chat. So most people don't chat in the chat, and they still look. So maybe I'm streaming for those people. But was anyone talking to me then? I don't see myself being highlighted. I just mostly is the spam bot. Last thing I did to react on, he said, I found my answer, Carlo. Thank you. Well, okay. I said, that's good for you. So what did I miss? Yes, I'm Dutch. I must say I'm starting to react less and less to the FAQ questions, like how old are you, how long have you been coding, since when did you start coding, how can I learn C++? Certain questions have been asked so often that I'm starting to not see them anymore, which is annoying of me. You can hate me for it, but that's the reason. And one of those questions is, are you Dutch? Ben jij ook Nederlands of niet? I think most Dutch people have a very clear Dutch accent. And if I do, unfortunately, then I think that's unfortunate. I'm definitely not proud of having a Dutch accent, but well, I cannot help it apparently, because everyone seems to hear it. I have a problem understanding why this is not compiling. But okay, let's not waste too much time on it. We'll just have to. Maybe we can use static cast instead then. Static cast group type, no whining allowed. There we go. So the default constructor of partition now sets all the elements in one group. Next we need a print on. My stomach is starting to hurt again, which means that I should have been eating 3 hours ago. I'm an idiot. An asshole, that's what I am. Okay, we're going to run over all the elements of our array. Let's call that G. And then we're printing each group. Simple as that. Standard O-stream reference, print the group. To OS, except when it is empty. If M groups G is 0, don't print anything. I'm just quit, break. Otherwise we print it. And we have the comma, so we do a prefix, the prefix trick. And after having printed one thing, we set a prefix to a comma, and we add a character const pointer prefix that is empty. Pointer. Moreover, we're going to print a brace at the beginning and the end. But yeah, actually I also want to have braces around my group. I don't think that it's doing it yet. Maybe elements print on. So this prints a single group. Let's not use spaces here. Let's not even use commas here. I'm just printing all the elements one after another without commas. It's kind of more terse, so that seems nice-ish. And then in order not to get confused with the others, let's turn this into angle brackets. So angle brackets for groups. No, for partitions, sorry. Angle brackets for partitions, and then braces for the groups inside the partition. Standard O-stream reference operator less than standard O-stream reference OS, comma, partition const reference partition. This was a friend, which I always seem to forget. And then we do this exactly the same thing as always, namely we call print on. Okay, now can we print this? Do I already have a partition? I think I can make a partition. Let's not do this anymore, this already works, right? Let's make a partition P and then just print P. Nice colors, compiler. No match operator equals operands are standard array elements 16 value type, aka const elements, and int. Nobody gets it. Oh, okay. If elements equals 0, yeah, I'll have to convert that to something. Elements. How do we convert elements to the value? No, that's nice. So now we have a partition, right, with a single group where it contains all the elements. Awesome. Hey Redsin, how are you? I'm implementing just a little test thingy that contains of 16 bits for group type, and then we have an element index, which is just an integer, which runs from 0 to 15 as a class. And I have an element which has a name for debugging purposes. And one of those 16 bits, which is just one bit is set. So each bit has a name, so we run from A to P. And for laziness I also have the index, 0 to 15. So this is just a single bit, really, an element with a name. And then of course you have the class elements, which is then the plural of element. So this is bit 16 bits, and then 0 to all 16 bits can be set. And we can add bits, or remove bits, toggle bits, print them. And now I'm adding a partition, which then is a way to partition all these 16 elements into well, groups. So either we put everything in one group, or we put just a few in a group and the rest in other groups. And I thought I had this somewhere in a file. It's probably if this is the last directory where it was in, I switched here. To partitions, partitions. Yeah. So I wrote in, this is then an example. If we have 5 elements, then we can partition them all in one, or we can partition them, if for example A and B in one group, and C and E in one group, and D in its own group. Or we can partition it A and D in one group and the rest in a group, etc. Right? So there's lots of ways you can partition it. And I want to find the best partition. If 2 elements are in the same group, that can lead to a penalty, and if 2 elements are not in the same group but they want them to, that can lead to a penalty. Okay, let me see. Now we begin with all the elements all in one group. I realize, however, now that I do not have a support for n. I should have that. The maximum value of n is 16 at the moment. But what if I want less? Let's add a const n, which is 5. Make it a const expression. Well, then it does not run anymore from 0 to 15, of course. It runs to n minus 1, right? And I'm afraid that even this is then not longer correct. This must simply be n. I have multiple of those size-offs. Let me see. Array. The size of the array is maybe not important, but on the other hand, you can do with n groups. No other size-offs. Assert might be important as well. And you have an assert that does already. Okay, so it should work, except for one more thing. Well, these just list everything, so I should now get a search on if I go past the 5. Okay, well, maybe then just not do that, you know. We have only 5 of them, and there's one more thing. Here I have a -1. But what I really want is a value that is, well, you know, 1 shift left and -1. Now I get only E. What? Oh my. Oh really? I meant this, you know. And A, B, C, D, E. So now n is 5, so we get 5 elements all in one group. Okay, now we want to be able to change this into another partition. And I want to do that by toggling one of the bits out of the group where it is in and adding it to any of the other existing groups or add it to a new group. That's a lot of possibilities, I have to admit. So we almost call it permutations, as it were. Now suppose we have in total G groups. Let's say we have 3 groups. Then all elements belong to one of the 3 groups. And I pick any element, which I then remove from that one group. Then I cannot add it back to that same group, that would not be a change, but I can add it back to one of the other groups. So that gives us n times g minus 1 possibilities, plus n if every group is larger than 1. If an element is on its own in a group, however, then I cannot put it in a group of its own, because that would be the same as putting it back. So it might be a little bit less. But in this case, it would be exactly one group. So G is 1. So G times 5 is 5. That's 5 possibilities to change this. Yeah, I think I'm going to run over all elements and then over all groups, and then simply skip what is not doing anything. And I'm going to have a function like next permutation. Is that I don't know, permutation maybe not the right word here. Next configuration, next partition. It's probably best, yeah, I think. So we just change the partition, go, yeah, next partition, or generate yeah, it's okay. So just we go from this partition to another partition in a loop. So there's just going to be something like next partition. That means we have a partition iterator. I'm going to make a class. I call that partition iterator. And that is the iterator is going to be like like having those loops as private members. So I'm gonna have I think an integer that runs over the element indexes. I was sorry, I do have an element index. I think about it. Yeah, we have an element index. It is indeed an integer, but well. So this thing is going to run from 0 to n-1. And then I also need to have an integer that is for my for the group. Could make a group index, I suppose, but well, I'm getting lazy. We have at most n groups. I'm going to start at 0 with both of them. That is element index default constructed will give me 0 or not. And we do not have a default construction. You can construct it explicitly from an integer, however. So let's do that then. So this one is 0 and this one, well, might as well add a 0 here as well. The same thing, empty or not, gives you 0. Now, treating this as a true iterator, I must have a partition operator star. So we call if we do a star in front of a partition iterator, then I want to get a partition, the current partition. And I think I'm going to do that by storing the original partition. Might as well make a copy. You can also do this as a reference, but partition is so small, I might as well make a copy. And then we just take the original and then we apply whatever the transformation is, and then we return it. So that would be something like partition p copied from or assign it original, and then here we apply the transformation, and I'm going to return p. So some code required here. And then next, doing the next one, it means calling operator plus plus. So that would be returning partition iterator. Also she had unknown logic. And then that returns also something. No, that returns as ourselves. Which might be equal to end if we're done, right? If we try to go to the next one, there is no next one anymore. We want to have a value that is equal to, there is nothing else. There would be a special value. Let's make a default constructor here that makes the special value. So partition iterator default constructor as a special value. Well, element index could be anything, but let's use whatever. Let's use let's use a don't care. Hell, I don't care so much that I don't even mention it. And a group as an integer, that's much easier. I'm going to set it to -1. That means end. Okay, that might not work because I want to, if we want to be able to compare with end, well, actually that should, it just should work. Okay, as long as I take it into account. Yeah, well, maybe, I don't know. Anyway, I need an operator unequal. Let's not make it a friend in this case. So that, call it the right hand side. So there I have the special case m in index equals -1. So equals -1. Nah. Okay, I'm lazy. Let's do it differently. So that means that it's not equal, and equal means that both index is equal to the right hand side index. As well as m group. Yeah, and now I don't like it anymore, and that it's a friend. Sorry, not a friend. Let me add explicitly this left hand side. But if I want to be able to use this as a put it inside of here. If you want to use this to compare with end, then I should set end as well to some value. If it would be random, it would not be random. It would be, if I don't mention it, it's going to be 0. Because I put a 0 here. I might as well not mention it. But I don't know. I'm adding it here because if I do it like this, then really index must be 0. in order for it to be equal to the end value. Okay, so how does this work? Well, let's begin with leaving these things completely empty, and then see if we get it to work or compile like that, or like this. I still have to make be able to construct this thing from an original. Let's call that partition original. And then the index and group both start at 0, so now I'm not mentioning them. Okay, so we have a partition, and I'm going to make a partition iterator. Partition iterator. Well, it should be just begin, right? So I must have it now in partition iterator begin in partition. Which means that we have to declare the partition iterator, and then we're going to return here a partition iterator, I think, begin and end. And then after we know what the iterator is, how that is defined, we can define these things. For the end, this returns the default constructor. And begin returns a partition iterator that is constructed from the partition itself. And now we should be able to print the dereference of that iterator. I already see that it is an iterator with a fact that I call begin, so we might as well use auto here. It's more like a convention thing, but okay. I think this should compile and then print the same thing as before. Expected semicolon before. So that worked. Great. Now I have to implement the logic. The hardest part is detecting when we get to the end of the group. It depends on the number of groups that we currently have. Let's say I'm adding a speed up here by just remembering the original number of groups. So I'm calling that original groups. Which is a constant, but let's not make it a constant. I might as well make this a constant. Okay, while I'm at it, make it a constant. Because it's our end value is 0 here, and this is already has a default constructor, doesn't it? Class partition. Yeah, we have a default constructor. Default constructor just sets all the bits. Okay, let me make sure this still compiles. Okay. So constructing it from some partition, I want to set also the original groups, just the number of groups of the original partition. Well, I'm going to keep this array sorted in descending order, so that number of groups is simply equal to the number of elements that is non-zero. Rather, it's equal to the index of the first element that is 0. So I can simply run over the size of m groups. And now we do if m groups is empty, break, return G. So as soon as a group is empty, then that index is returned, and that is then also should also be equal to the number of groups. For example, if we have no groups, then all groups are empty. So for index 0, it's immediately empty, and then we do immediately break and we return 0, and so on. And it also works if every element is in its own group, then even n-1 is still non-empty. So we still increment that to the maximum number of groups. This should be size, which is equal to n. So then G is n. I think we have An empty in group, right? Class group does not exist. That's interesting. Oh, that was group is elements. Empty, yep. Right, in that case we can continue with. So now I have the number of groups in the original. Well, we are going to move something out of the original groups, and unless the number of groups equals the number of elements, there's going to be at least one group that has 2 elements in it. And if I remove the one element of that group, we still have the same number of groups, and I can create one extra group. So if it is less than n, it could become one more. If it's equal to n, then of course not. It can only become less. So I think that for what I should do maybe is just remember the group I want to put it in now. Group just simply a maximum value. Let me see. I need to know if the current element is alone in so the element index of the thing that we're going to move must be initialized. Yeah, index, they should be initialized in the order that you put them in. So index is initialized before index is alone. If I don't mention it in the initializer list, it's going to use whatever you use here. It's kind of the same as if I have index brace 0 brace in front of here. So at this moment, index is already initialized to 0, but at least I have to get the correct type immediately. So now I can make a variable is alone in original in partition that will return if that index is alone in a group. And I will take an element index then. Is alone, adding is alone to partition. Well, to know that, that's not an easy question. I need to find the group where it is set, so you have to run over all the groups again. To run over all the groups until we find a group which has this index set. Now m groups is an array of group. And let me have a look at what the group was again. Really? Group is still elements. Don't cry. Elements. Maybe I should rename elements back to group. Getting tired of this. Yeah, we have the usual bit manipulation stuff. Add, remove, toggle. Might as well add and test, right? Test a single element. Let me see. This should work. Element will automatically convert to a group type with its bit, and then we do a bitwise AND, and it's a Boolean expression, so we probably should undo, redo. Shall we put parentheses around it? Otherwise, the compiler thinks that maybe I mean this, and it's going to give me a warning. I think. In a way, it's pretty usual to put parentheses around the bitwise AND. And if this bitwise AND is then non-zero, then we return true. So that means that it is set. Test is the same as is set. And I was writing something somewhere. Is this going to work? I don't think so, because we have an int and I want to convert that into an element. I have to go to element again. We can only convert it from an element index. So I can make my int an element index, I guess, which is allowed by explicitly converting it. Now I have to go back again to where I was. Okay, that was a 4 into, oops, into G. Or the next one. There must be a cleaner way to run over element indexes. Something is not right here. Totally not right. This is bullshit what I'm doing. Sorry guys. index. The question is if the element with index is set. Now it should work. I would rather have an element, but okay, test takes an element now. Test takes an element, yeah, but element can be constructed from an element index. So that should work. Okay, so then as soon as this element or element index, all the same thing, if that is set in the group, then we found the group. And then we want to return true if that is the only bit set in that group. And that is the case if it is a power of 2. So we need now the value of that group. So that is this group here. Which returns I'm starting to be more and more dirty because it's getting later and later and I just want to finish it. So I'm sorry for that. Oops, elements. Nah, I might as well add it here then. Ball as single bit like this. Okay, I already test if M group is a single bit. It is a single bit when M group -1 and that bitwise end with M group has no bits set. So true, totally true. So now I have is single bit, so what I really want to know if this is a single bit. Type. So run over all the groups. If we find the group where that thing is being set, and we must find it, otherwise use bug in the program. Assume I have an assert for that somewhere. So as soon as we find it, and then return if it is alone or not. And now we have this function implemented, and I don't need these braces, so I just normally don't use it. One braces, one that's not needed. Just coding style. Neovim, yeah. Okay, so now we have here now this is initialized, at least, if it is alone or not. Now we pretend that these things are for loops. Sorry, the index is a for loop. This is the outer for loop and this is the inner for loop. So if we do ++, we want to increment the inner loop first. So I'm going to increment M groups. And if then that becomes equal to that becomes equal to the one past the final group, so it's just not possible. And then we want to return yeah, this still, but I want to set the current. Then the iterator must become the end iterator. So what I can do is just assign, I guess, the default constructor, which is end. The question is, however, what is the group that is not possible? Well, if depends on if this element is alone or not. So if the current element is alone, then it's one thing, and otherwise it's something else. Okay, time for some ASCII art. Suppose we have the following partition. We have A, comma B, and then we have C, comma D. This N is 4. Then automatically this is going to be group 0, and this is going to be group 1. Well, actually the other way around. If you say that A has a smaller value bitwise, and we want to sort this array in descending order, so the CD comes first. And then AB, and the rest of the elements are 0. Okay. So this for N is 4. Index 0 is now group. It is an array. Then maybe I should. Yeah, well, it is a partition, but the partition exists of an array. Where's my partition here? There's the partition. A partition is a wrapper around an array. The array has exactly n groups. If n is 4, we have n elements in our array. And this is just the bits that are being set. And since C and D have a higher value, they are first. And the 0 and the 1 here are just the index of the array. So this is 2 and 3. Now I'm going to move A to a different group. Okay, so actually let me say, no, it's okay. So the different things that I want to generate are A being moved to the first one, or A being moved out of the B group, moved to its own one. So the highest value of G is 2 in this case. And the reason is that A is not alone. But if A is alone, so if we have this, sorry, A is alone. So we have B here, and A is alone. Now the only possible way for A is to be completely removed from this group and be put in here. So now the maximum group value is 0. So in this case the maximum group value is 0, or rather in this case. And in this case the maximum group value is 2. Maximum index. But okay, I want to know the end, so 1 past the end, so I'm adding 1 to it. Oops. So I want to find 1 here and I want to find 3 here. And the 3 is in fact 2 plus 1, where 2 is the number of groups. And the 1 is in fact 2 minus 1, where 2 is the number of groups. So I need the number of groups of the current of the original partition, and we had stored that here. Original groups. It's a number of original groups in the original. And then if A is alone, that's this one, we have to subtract 1, and otherwise you have to add 1. So if after increment is a pre-increment, so if group after incrementation is equal to number of groups, 2 minus 1 is 1, then we went from 0 to 1, and then we're done. While in this case, if we went from 2 to 3, then we're done. Now there is still a problem that we are already done at the moment that we are at 2, because A is in the group 2. So I want to skip 2. So I also need to know the group that A is in, so I can skip it. So I need more information even. And to know if it is alone, we also want to know what group the current index is in. So M index group, which also must be initialized. So we have original, and then we want to get the group of M index. Might as well do the conversion from index to element right here. So this is group of, we wrote earlier is alone. And this is take an element index, but why not just take an element? Test takes an element as well. And now I want to add a function. I don't know what it returns. It was group of. Sorry, group of is being stored in M index group. That's an integer here. Why would it be an integer? Okay, yeah, I am using integers for group indexes, and on that I was lazy. I should make a group index class. That's much easier to understand than using integer for all your indexes. So I got lazy. I do have an element index. You should also make a group index, and then you just, you cannot make mistakes. Indexes should have their own classes, even though they are integers, I think. But we got lazy, so in this case we're stuck with an int for group indexes. So we return the group index here also for an element, which then almost does the exact same thing as here. We just find which group it is in. And now we return that. Could also first find the group and then ask if that group contains a single bit. I guess that would be minuscule faster, but well, whatever. Okay, now we're going to make this a do while loop. And as soon as we set this to end, we just break out of it. Well, pretty much done at that point, but we want to skip if m group equals the current group, so it's just not. So if that is equal to index group, we want to skip it. So now we would get if the group is 1, m group is 1, and we increment it, it becomes 2. 2 is not equal to 2 plus 1. So we do not do this, but 2 is equal to the original index group. Therefore we do it again, and now we increment it to 3, and now it is equal, and then we set it to end, so we're done. However, we're not really done. What we want is to increment this one, m index. So in fact, if this happens, and then we are at the end of the group and we want to increment the index group, and then return plus plus, I think. Or is that nonsense? That is kind of nonsense, right? No. This is going to be not true, but this might be true. Yeah. Okay, so when we get to the end of the group, then we set m group to 0. Start over, and we increment index. And then if m index, can do that as this. If m index, if an index reaches the end, then we are totally done. Then we are totally done. But if not, we can just continue like this, I think. However, m index group changed because we changed the index. So we do have to, now we incremented index, we must update m index group. And if it is alone as well. So these two things must be initialized, re-initialized if m index is being changed. And then it's theoretically possible, I guess, that now m group being 0 is still equal to m index group, in which case we will want to skip it. I think this should work. Yeah, that should pretty much work. I think I implemented the increment thing. Now we still need to implement the dereference one. Yeah, so that copies M original, and then we have to apply the changes. Meaning we have to remove M index from its current group and then add it to the other group. Well, that's simple enough because we have all the variables here. So we have this is the group it is now in, and this is the group where it has to go to. The naming is a bit not really, you know, intuitive, but I'm gonna stick with it for now. Don't know, it's just a test program. So we have to do something like partition. Sorry, I have to look at how partition worked. So alone group array, yeah. Probably need to add an accessor of that then. Yeah, let's just add an accessor or add this thing as a friend maybe. Iterator can be added as a friend, I think. So I'm gonna add friend. Oops, what the hell? Right, so I think that should do it if it compiles. So M groups contains M groups, that was up here. M groups contains a group, of course, and then a group is elements, and elements has a add and a remove, which takes elements with an S. And the thing that I did here was M index, and elements with an S is taking an index or not? Probably not. Let me think. No. Elements. It takes an element. Okay. Well, an element can be constructed from a single element can be constructed from an element index. There. And not explicit, and so all those conversions should happen, I hope, or think, or maybe not. Cannot convert const element index to elements. So no, then, well, okay, so I'll just making it explicitly an element of it first. I mean, it knows how to convert, I mean, it takes an element and it knows how to convert an index to an element, but to do both, anyway, that's a bit too much. I mean, the next step would be that it just writes its own program. So yeah. Expected semicolon before number constant. Errors keep coming. No match for operator equals element index and int. Yeah, that should be I end, isn't it? Called on. See, I end returns s I end, which is s, and this is simply a static thing of element. What? No match operator equals element index and the operand types element index and element index. Oh, okay. I'm adding an operator equals. Use a deleted function, partition, iterator reference, blah blah blah. Move. Move assignment. It's being annoying. Yeah, I'm assigning to a class that has const. This is a partition iterator, and the partition iterator has two const values, so I cannot assign to it. So I'll have to add the assignment operator explicitly, or just do the whole, make it an end value directly, I think. So when was it an end? It's an end when index is 0 and m group is -1. Yeah, well, it should never reach this. We're really going to assert false. Yeah. It should never reach this. I think that still gives an error. I mean, if I was using my own libraries, which normally I always am, of course, I could just do, I think AI, never reached. Nope, never reached. No. What? Oh, I don't have a tag set here, of course. I think it was AI never reached. We don't have that now, so yeah, I just have to return something, anything. Right, okay, now we can iterate, I hope. I mean, it compiles, but it must still work. So let's say this is the original, and now I'm going to iterate over this. So I'm going to do an autumn iter is... oh, the PI is already an iterator, right? Yeah. So iterator, let's go, okay, let's call it PI. Partition iterator is p begin. Pi is unequal p end plus plus p, and let's see how to print pi. Cannot increment the partition. I meant the PI, of course. Yeah, that didn't work. Which not at all. Okay, so let's run that in a debugger. Let's see what the hell is happening. Partition P. We can print P. So okay, we have elements which exist of. Well, I never sorted the thing to sort it after changing it. Nevertheless, still should not happen. It's too difficult to explain again, I'm afraid. It's going to change partitioning, so that's as soon as it prints something, it will become clear what it is doing. Okay, so we have 16 groups, and the last 15 groups don't have any elements, and the first group has all the elements. It is 15 bits here, no? 16 bits. 16 bits. Yeah. So that's not 16 bits. 31. 5 bits. N is 5. Yeah, we have 5 bits. Sorry. So now I do step. We are going to inside begin. Which creates an iterator from this, which just stores the original, where original is our thing, and it stores the number of groups. It should be 1. Let's do step anyway. So next is empty, break, return G, print G is 1. So we have 1 group. Original is 1, that's correct. And index is alone for index. Oh, this is inside the iterator. Yeah, index is simply 0. So we do a step. We get into element with 0, and then we get to it's creating an element. Oh no. Yeah, step, lots of steps. Assert. Oh, I can do next here. Watch is alone, finally. It's not alone, so this should return a single bit is false. Yeah, well, I believe that. Oh, I should have stepped into it. But anyway, it's going to return false, right? So that was initialized now, and then this one is false. And it isn't. It's not even initialized yet. Now it's false. And now we're working on the group of, and so that should be 0. It should be set to 0. So G is 0, test element, yep, and we return 0. So that one is set to 0, and then we have our begin. Now PI should be that, so I should be able to print it. And indeed, we have the original is our original. Ta-da. Group is our iterator. They start at 0. Original groups. Well, the original has one group. It's also correct. We saw that. Index 0. So our loop variable. Index that is 0 is alone. No. Index group is the group that it is originally in, I guess. No, yeah, there was already that index, which is 0, just so A is in and is always 0. Group is the group that we want to move to. Yeah, so we begin with 0. Well, we're going to skip that. We are not going to move A from A to A. Now we're going to test if PI is unequal pend, but it is. Otherwise, it would not print anything. So step into it. Let's step into it. This is going to return the end returns a default constructor for the iterator, which just sets index to 0 and group to -1. Simple enough. And this is then what compares that. So we compare index, which is 0, with index, which is 0. And we compare group, which is 0, with right hand side group, which is -1. And therefore this one is unequal, so we return true, meaning that it is unequal. Therefore we print it, and that's everything is just in one group. That alone is kind of strange, but that's where we begin, I guess. I did not step into the iterator. Yeah, that's nonsensical. Let's run from the beginning. Continue. Step. Okay, we begin with the original. And we're going to remove element 0 from group 0. Which means that afterwards index 1 is removed. The new variant is there. P. Is it correct? Yeah, of course it's correct. And we're adding it to group. The group is still 0, so we're just adding it back. That is definitely not correct. I should have done an increment first, but doesn't matter. That's one bug. It still should continue printing. So this just added it back, and it's the same thing, and it printed that out. Okay, next, and then now we're going to call the ++pi, which is much more interesting. You know, I think I did it again, or not. Probably need parentheses around this. Yeah, that's a bug. How annoying. 259. We can still continue. So now the question is 1 equal to, well, is it alone? No, so this is false. Therefore, original groups is 1. Plus 1 is 2, so is 0 plus 1 equal to 2? No. So what we're going to do is we continue right there, and we're going to do this while loop. So I do next, and indeed we are at the while loop, and then it says is m group incremented in group equal to the current group? Nope, so we're done, and we return this, meaning that well, the original is still the same, of course, but now the group is set to 1. That's the only change. So if we dereference it, we're going to remove it from 0, and now we're going to add it to 1, and then we get this. Now we have 2 groups, so A was moved from this group to its own group. So if you print that, then we get this output. And then if we do a plus plus, it's going to say if is 2 equal to 2. Yes, so now we stop. Set m groups to 0, and now we increment m index to the next index, which means that well, this still false, and this group is still the same thing. M group is yeah. Now this is funny. Yeah, this is true, because M group is 0 and the index group is also 0. So we continue, do it again, but now it's unequal, and then we're going to print that. And we get that B is put out of it. So I think I'm just going to run it soon. So from here you can see what the result is. So this is the original, and then it's moving A out of it, and B out of it, C out of it, D out of it, and E out of it. But the first one was nonsense. I shouldn't. This has done nothing. Or I should begin with an increment, maybe. Probably makes sense. Begin with an original, and then we do an increment. Yeah, let's do that. Yeah. No, I should not begin with an increment. Begin should just return the first permutation. So, okay, I can do an increment, but then I should do that from begin. And I rather just change begin, I think. Where's begin? Here's begin. So I create an... If I create an iterator, it must immediately do it. What is it? Must immediately do an increment. I need an... Yeah. Okay, I can call operator plus plus from here. And just do it like this. Okay, let's print the original as well. And anyway, though, here. Okay, now let's try another one, like, why not just try all of them? Yeah. Can we do that? So making another loop inside of this one. Probably should give that a different name as well. Oops, let's make it a by 2. So we make, first we put A outside of it, and then from there we move B from here to there, or we move B from here to out in its own group. And then we do the same with C, so B stays with C is put together with A or in its own group, and the same with D, and the same with E, and the same with yeah, E was the last one. And then we have B already outside. So we do that, then we do the A, and then we can move it back. Ah, I missed that here. What's happening here? Why is it not moving back A here? Start with B here. It moved B to A. It did not move A back in. A did that with B though. It starts with A. A is being moved to B or outside, and then B is moved back in here, and that's it. It cannot be put, you know, on its own, because that was already the case. And then here we have the C. C can be put together with B or on its own, and then for the D and the E is the same. And here we have the A can put together with the C or outside, same for the B, and the C can move back. So everything looks absolutely perfect except the first one. With this as original, it's not putting the A back. Why not? Okay, I think I have to call it a day, guys, because it's just going on and on and on, and it's getting late. So I'll continue tomorrow, I think. But why is it not putting the A back? Can I create this as a beginning, as the it should be able to. No, we can only create this manually. Nevertheless, I have it. Should be able to debug it. Okay, I'm gonna. I should not, but I'm going to debug this one, and then I stop. Break main. Run. Next, so that's everything in one thing. Incremented. Next. Okay, now we have B2. It exists of first group is this, and the second group is this one of them. It's even in the right order, even though I never had to sort yet. Okay, so I call S, which means that we are going to construct it from this and then call the plus plus iterator there. It's going to take a while before we are in the plus plus iterator, I'm afraid. I don't want to see this. I don't want to think about it until I can see it. I mean, explicit. Just want to set a breakpoint. elements, partition iterator ++. There it is. Break 248. Continue. So now I am in the ++ thing of a partition iterator, and that partition iterator looks as follows. The original is indeed B, C, D, E, and then A. There's two groups. We start, of course, at 0. M indexes and two M indexes. Confusing. Index is alone is true. Well, no matter what, this is A. A is alone, that's correct. And the index group, that is that is the group that index is in. So A is in group number 1, that's correct, and we want to move it back to 0. We want to move it back, so it looks completely correct. And then we're going to execute this line. So M group is going to increment with 1, and then we say if is that equal to, well, this is correct, and original group is 2 minus 1 is 1. Aha. So it thinks that it's immediately at the end. Is that correct? I guess so. M group is 0, right? So M group is now 0. So after increment, it's going to be 1, and this is true. Therefore, we are getting as value here that we compare with. Original groups minus 1 is 1, so it's going to be equal. It's immediately stopping. When we think about it, why is that the case? Okay, I know it. I see it. And now we can stop. The problem is, or rather the mistake is, that last change I should not call increment here. Instead, I should, in the dereference, okay, I can do that there. Let's not do it in dereference, I'll do it here. So if this is equal, and then I should increment, I think. Yeah, now it works. So the original is this, and then A is being moved back. And now we get B and C in the unit. So now it works. We have an iterator that changes a single element from any partition into another partition. So the next step is then that I'm going to calculate the penalty for the new partition, and then we'll pick from all these iterators the lowest value of the penalty to the least penalty, and then again and again and again. And then the big question is if that allows us to reach the minimum really quickly. I mean, like much quicker than brute force would do. To be honest, I have no idea if that's true, but it just might be the case, you know, just like this this question here. Well, that's not the one. So my feeling is that we have a multi-dimensional problem of this case here, where instead of brute forcing for every possible thing, you just make linear steps. And in our case, cannot be linear, but it's probably fast enough. The only problem is that it's hard to test. The only thing I can think of to test it is with Monte Carlo thing. So then we have to do it brute force as well to make sure that we know the answer, and then for random penalty formulas, C of E always reach the optimum case. That would be true, then this algorithm works. But I'm going to finish the algorithm tomorrow, okay? Good night, everyone. Thank you for keeping me company. I hope you learned some C++. I'll scan one more time over it for those who are really interested in learning this. Okay, so you have to include headers for everything that you use. You do not want to hard code any constants. Always use a variable or a const reference in C++, recent C++ standards. And even for something like this, you know, I use an uint16. If I would have hard-coded uint16 everywhere, then it would be difficult or annoying at the very least to change it. So rather I just give it a name, and then I can change this later to 8 or 32 or even 64, and then the code will still work. It's much better. Also, write a class for everything, even if it is just an integer, especially when it is an index. Index into an array, something that enumerates something. That's a lot of work, because then you have to write all those things that normally work directly for integers, but it's you know, a benefit really. Sometimes it's a bit awkward, like if you want to really get the integer value back, and sometimes you will, you have to call a strange function. Might look weird at first, but that's the whole point, that you cannot simply get an integer back. So you have to do some special hard work, like typing get value to get it if you really need it. Same thing the other way around. By adding explicit, it's not that easy to even create a thing from an integer. You have to explicitly pass an integer to create such a thing. You cannot say pass a float or a double or even a char, I think. I'm not sure if a char would do the explicit conversion, by the way, but okay, so yeah, you have to implement all those operators, and we are only using a few here, just pre-increment and then unequal, equal, and less than, but it could be a lot of them. But I think it's still worth it. Now you already see really an element is just a bit mask, but okay, we could speed it up by having a second variable which is really encoding the exact same information, and we have a debug name that we can print all in one. There are easy conversions between all of them, so these are static functions here, which means that they're not member functions. They just take an input and convert that without using this state. This is the state of the object, and those static functions are just functions that return something that only depends on the input argument, and the result does not depend on any of these things. So it has little to do with the element. And why do I add it here? Well, because, you know, it's what it encodes is very, very much to do with the class itself. Like I said, these three really encode the same data. Capital A is the name of the first bit that is set, which has an index of 1, and a capital B means that the second bit is set, which has an index of 2, and so on. So index of 0 for A, of course. So the name is really equal to the index plus A, exactly like you see here. And the same thing holds for index and bit relationship. You just shift left a 1 with the index, and you get the bit. So those conversions are fixed. And here you see again, we use constants instead of hard-coded values. Yeah, I'm not going to use a 0. I'm going to use a thing with a name. And if you put that inside a class, it's not a const expression. You have to add a static const expression. And then every class must be printable. For debugging, you really want to have this operator. And then my convention is to always write everything like this, just the type of the class itself, that this is a friend of. I should not need a friend here, because the only thing I'm doing is calling a public member function, print on. So it does not need to be a friend, but normally those things are a friend, and by calling it a friend, I can put it, even though it is a free function, it's not a member function, it's a free function that is just in global namespace, I can still put it inside the class. So what you can also do is this closing brace, put that here, and then remove the friend. That would also work. So we see this for everything. In this case, we just print the debug name here. Elements is the same thing, you know, here. There's a print on as a member function, and the same type of free function here, which I call a friend, so I can put it inside the class to make clear that it's really, very related to the class. In fact, what I did for my own code is I do not add this. I have some global magic that implements writing anything, not just elements or element or whatever. It writes anything to an OStream if that anything has a print on. So I have some kind of magic somewhere in a debug header, which I always include. So then I do not even have to define this. I just define print on, and bang, I can write my classes to an OStream. What else is there to say? Okay, so elements, then again a wrapper around an integer, but we don't use uint16 here. We explicitly give it a name, and now it's clear that this is a group. And we implement things, you know, you could, for example, here say, oh, I must check if it is empty, which means that no bit is set, so I must have the value. So I add an accessor for this value. And then I compare it in the calling code, if it is 0, to test if it is empty. But it's not what you want to do. What you want to do is know if there are elements in this group. Let's call this a group. So when you want to know if it is empty, so then call it like that. Make it a boolean empty, not an accessor that returns a group type. And same thing here. It is a bit mask, but that is an implementation detail. What you really want is add elements to it or remove them. So give that the name that what you really had envisioned. Hiding the internal things like that. In fact, it is a bit mask. Okay, now we get to the partitions. Well, again, implementation detail is that I simply, for the maximum number of groups is n, I just add a bit mask for each possible group, and then groups that are completely zero, aka empty, are not really groups. I could make it a vector and then only store the non-empty ones, but this is slightly faster and it works as well. For the rest, it's a very small class. I just have a print on and okay, oh, that's not true. We have here a few things here that I added later. Really by name, you know. It returns the number of groups that it has. This returns if that element is alone in its group. This returns the group index. And again, I'm returning an integer. This should really have been also a custom class, let's say called element index. That would have been better, but that was more work and I did get lazy and I did use an integer in this case. Now this is a bit more advanced. The partition iterator is probably only something that you would say, okay, I understand why you did that. When you're more familiar with iterators, iterators are a very well-known concept of the standard, especially STL, standard template library. If you know containers, you know iterators are things that point into elements of standard containers, like a vector of an array, of a DQ, of a map or a set or a multi-map or whatever they have. And well, you can write your own iterators, which have to conform to a lot of difficult things, which I definitely didn't do here. But I borrowed vaguely the idea of it. So we have an iterator, and that's really a pointer to something, and you can dereference it by putting a star in front of it. And then what means calling this function, and then you get a partition. So this is a partition iterator, and I dereference it. It's not really a pointer. I'm just calling this function, and I'm calling it a dereference. Well, really, I mean, I could have called this do your thing, and I would call the function do your thing, and then I convert this partition into a partition, the one that it is pointing to between quotes. It's pretty far from the real iterator stuff in the standard library, but okay. Hell, this is not even really pointing to a container. It just copies the whole container. The original container that normally it would point to is now copied inside the iterator as a constant, and then we do the transitions on it every time I do a dereference. So it's really like a rape of the idea of an iterator, more like than a real iterator, but okay. Nevertheless, after having implemented it, which was not too easy or trivial, I have to admit, the feeling is a bit the same. You know, you can do stuff like auto iterator equals p2 begin, iterator is unequal p2 end, plus p2. That's how you write iterators if you want to iterate over all the elements of a container p2. And in this case, p2 doesn't contain any elements. P2 is just a 16-bit integer. No, it's not true. It's a partition. It's an array of 16-bit integers. But my iterator is still iterating over something. It's iterating over all the different partitions that I can derive from it by moving a single bit from one group to another group. Okay, I hope that was clear, and I'll see you another time, maybe tomorrow. Good night.